Hello, linear algebra student. This video is for chapter 3.1, part 2. I'll continue with determinant of matrix. Of course, other than in the last video, we talked about to find determinant by cofactor expansion. So that's doing it by hand. There's a lot of tricks that we can do as well as calculator. So I'm going to talk about the calculator. The portion of it is here. So if I have a matrix, 2 by 2, 3 by 3, I can actually calculate the determinant by inputting the matrix and then use the determinant features. So yeah, if I scroll down, you can see that there is a determinant. Here, determinant. So you can say determinant of A, and they would calculate for you. Okay, like that. The second tricks that you can use to do it by hand for a 3 by 3. For a 3 by 3 matrix is called the diagonal tricks. So what happens is you write your matrix like a grid, and then you write 2 more columns so that you can do 3 diagonal. On the positive side, the main diagonal along with the main diagonal, you multiply these 3 entries together and you add them together. On the off diagonal, you also multiply them, but they would be the opposite. You add the opposite together and you add the 6 product together, and that would be the determinant. It's very fast. So let's illustrate this. So I have a 3 by 3 matrix, 1 2 3 2 3 1 3 3 2. I want to find a determinant of it. Of course, you can use the decimal calculator, but it's also good to know the tricks, because in some cases, if you have like variable in it, there is no way that the calculator can help you. So you really need to know them. And in calculus, sometimes you run into this where they are variables. So to do this, we would have to copy 2 more columns. 1 2 3. The first 2. Don't have to copy the whole thing. Okay, 3 3 3. And then I'm going to do the main diagonal. The first is 6. This is 9. And this is 4 times 2 is 8. 8 times 3 is 24. So I'm going to add them together. 3. And then the main diagonal would be this. 3 3 4. Negative 36. They are the opposite. Okay. 3 1 1. Minus 3. 2 2 3. 4 times 2 is negative 12. Right. So the determinant of A would be, it's very fast, equal to 6 plus 9 plus 24 minus 36 minus 3 minus 12. So that would be how come I have a minus 15? I don't think I have a minus 15. Okay, let's calculate it. This is 15 and plus 24. Just use the calculator. Okay, 15 plus 24 minus 36 minus 15. Oh, okay, so it's negative 12. Negative 12. And I think I have did it in the calculator. Let's see. Do I have it? Okay, I can override this. It's 1 3 4 2 3 1, right? 1 3 4 2 3 1 2 3 1 and 3 3 2. 3 3 2. So there, the determinant of A is negative 12. So that's exactly what we have. What's the determinant of B? Okay, so do the same because it's 3 by 3. Only if it's 3 by 3, you can use a diagonal trick. So 1, 2, 0, 0, 3, 3. Main diagonal 6. Main diagonal 0. Okay. Main diagonal 8 times 3, 24. Main diagonal 0. Oh no, back off diagonal 3, negative 3. And then this one also 0. So the determinant of B would equal to 6 plus 24 minus 3. So 30 minus 3, that's equal to 27. And I checked the answer, it should be right. Okay, so while we're doing this, you can see that it makes sense that if I have, anytime I have the zeros in the lower left corner or the upper right corner, whenever I multiply something, I will run into 0 other than the main diagonal. So we have this theorem, which is valid for all matrix, not just a 3 by 3. That is, in a triangular matrix, mainly either a lower triangular or upper triangular, you have 0 in the left corner or the right corner, then the determinant is just the products of the entries on the main diagonals. Okay, so this is a upper triangular because I have 0 all here, so I don't care about what it is, but the determinant of C would just be the product of the main diagonal. It is very good. So if you want to find determinants, you don't like for a higher level, like 4 by 4, you don't have a diagonal tricks. What you can do is to do elementary row operation to clear all the 0 at the bottom, and then the diagonal products would be the determinant. Determinant of D, this is a lower triangular because the upper right corners are all 0. So the determinant would be 1 times 3 times 2, also 6. Okay, doesn't matter what you have here. And the next is about elementary row operations. So what does elementary row operation do to a matrix? And how does it affect the determinant if there is elementary row operation? Obviously, we know that after you do elementary row operations, the determinant will change, right? So let's see, if I have a elementary matrix 100 K10000, then what is the determinant of this matrix? Well, we can try to use the elementary, the diagonal trick to do because it's a 3 by 3. So I'm going to do 1K 0, 0, 1, 0. So if you see this is 0, this is 0, this is also 0. And the other one is, oh, this should be a 1. Gosh, otherwise it's 0. I have a typo here. So this would be 1, right? I only have one entry. And the off diagonal, I have this one, which is 0, this 0, and all these are 0. So it's equal to 1 only. So even if I have a K here, it doesn't contribute to anything. Now, this elementary matrix is for what? Is for adding multiple of a row to like row 1. So this is row 1K plus row 2, right? Put it into row 2. And we know that this particular operation that is equivalent to an elementary row operation, it has a determinant of 1. What about if I scale something? So this is scale R3 by K and put it back to R3, right? So what is this 1, 0, 0, 0, 1, 0? So if I do the determinant of E2 would still be K, right? K, but all the other one is just 0, so don't need to do. This is 0, 0, 0. So when you do a scaling, the determinant is K. Great. So in the worksheets, in the class worksheet, I'll ask you to do some more maybe a row swap and also another combining rows to see what number they have. Okay, and then what operation does it have on a original matrix? When we do an elementary row operation, is as if we are multiplying them, right? So what happened is we have these 5 properties. It's not from the book, but I summarize it. If you want to find a determinant of A times B, it's actually the same as determinant of A times determinant of B. You find a determinant of A plus B is the sum of the determinant. If you find a determinant of a scalar multiplied by A, actually that is k to the power n, where A is n times n, right? To the power n to determinant of A. The determinant of the transpose is the same as the determinant. The determinant of the inverse is 1 over the original determinant. So let's just get ourselves familiarized with this. So we accept them, but we'll just show it that it works. Did I enter this 5, 2, 4? So maybe I'll pause it a little bit and enter the 2 matrix in my. Okay, I have entered my matrix. I call it E and F actually in the decimal calculator, and I actually did E times F, and then I do the determinant of E times F is negative 570. But what is the determinant of E? So I'm going to. What is the determinant of E times determinant of F? So they are actually also negative 570. Okay, I don't know the individual one, but I could. So we would say determinant of E is 30. Determinant of F is negative 19. And so when they multiply, it's negative 570. Okay, so I'm going to record this in my notes. So I call it A and B here. So it is, so we can write determinant of A is it 19 or something? It was E for me. Oh, okay, so I have to do E first. It's 30. 19. So this is 30. And determinant of B is negative 19. So determinant of A times determinant of B. You can use the decimal calculator to do. As it's negative 570. And then I would do AB, right? I multiply using the decimal calculator, and I have it equal to A times, E times F, 4029. 4029, 0. Oh, they always switch. 1243. And 18 negative 112. 18 negative 112. And then I have from it also is equal to negative 570, which is the same. So these two are the same. So do this. The interesting thing to do is, maybe we'll try the determinant. So is the transpose and all those. And the interesting thing to do is if you multiply A by 3, for example, 3A. And you do what is the determinant of A times 3? 3 cubed actually. So let's use the calculator to do. It was E for me, right? So I can say determinant of not E but 3E will be 810. And what is the determinant of E? E is 30. Determinant of E is 30, right? So 27 times 30, that's 810. 3E is 810. You can see that these two are the same. Okay, so you have to do 3 cubed, okay, instead of just 3 times the determinant.